This is question 9 of the Year 12 June exams. So this is a proof question. It wants us to prove that for all positive values of A and B, 4A over B add B over A is greater than or equal to 4. So I don't think this one's particularly intuitive for most people. So what I would advise you to do is to just, the only thing that you really would spot here is that maybe you should add the fractions together. So we'll do that and we'll rearrange it a little bit. And what we're looking for is to get to somewhere where we are writing a statement that definitely is true for all positive values of A and B. That's something that we can use and state, and then we could write our proof backwards, which seems a bit like cheating, but as long as we write it backwards in the end, it's absolutely fine. So I'm going to start off by just adding these fractions together. So I want a common denominator, so I'm going to multiply this fraction by A over A. So that would be 4A squared over AB. And this one by B over B, so B squared over AB. And that is going to be 4A squared plus B squared over AB. So I've now got to the point where that, if that is true, that is true. We've not proved anything yet, but if that's true, then that's true. So I'm going to multiply by AB. I don't really like having this fraction here. There's a chance that my cat might roll onto this paper in a minute. He seems to have jumped on the table. So, oh, here we go. Hang on. I multiply by AB. So 4A squared plus B squared is greater than or equal to 4AB. And I can spot here that if I actually take this over to one side, it becomes something that I can factorize. It becomes something squared, actually, which is really, really useful. So 4A squared add B squared, take away 4AB is greater than or equal to 0. And this is definitely true because I can rewrite this. It might help you to spot it if I write it like that. That is 2A take away B all squared. And because it's something squared, if A and B are positive values, then this squared, anything squared, is greater than or equal to 0. So we can use this to say this, to say this, to say this. And then, so if we write it that way out, we have got our solid proof there. If you've just written it this way round, then you would get 3 of the 4 marks, but it's not a valid proof that way around, but that way it is. So we just need to write 2A take away B all squared is greater than or equal to 0. We know that's true. Something squared is greater than or equal to 0. And then I'm just going to expand this. So 4A squared add B squared take away 4AB is greater than or equal to 0. Because if this is true, then this is definitely true. And then I'm just going to add the 4AB. And then divide by the AB. And then we know that that fraction is that. So 4A over B add B over A. 4. So it might fit. So this is our proof. That's the bit that we actually want marking. So it might feel slightly counterintuitive to do it backwards first, but if it helps you get to the right proof, then that's absolutely fine. Part B, says prove by counterexample that this is not true for all values of A and B. So this is one of those questions where even if you get stuck on part A, you can still do part B. We're just looking to find a value of A and a value of B where this isn't true. So up here, it says that it is true for all positive values of B. So that's my hint that it probably isn't true if some of them are negative, if one of them is negative or both of them are negative. So I'm just going to try some simple values. I'm going to go for A is 10 and B is negative 10. There are an infinite number of values that you could choose that this would be right for. So 4 lots of 10, if I substitute it in here, over negative 10, add negative 10 over 10. That ends up being, so negative 40 over 10 is negative 4. Take away, that's 1. So that is minus 5. So that definitely isn't greater than or equal to 4. So negative 5 is less than or equal to 4. So negative 5 is less than or equal to 4. So it is not true for all values of A and B. I'm sorry, that was a bit off the page, wasn't it? But hopefully you can see that now.